Hello, my name is Kyle Pazandek, and I'm going to give a quick discussion about an API technology that is quickly replacing database connectors and the REST APIs in many applications. I am a security engineer and a software developer that works in the Apple Enterprise Software Management space. What we'll be talking about is GraphQL. GraphQL is a query language over HTTP and works independently of just about any software language. The agenda for this presentation is as follows. I'm going to give a high overview of GraphQL and where it connects with SQL and NoSQL databases, limitations that exist in the current REST and SOAP APIs, and also how database connections are not ideal. From there, I will jump over to how the schemas, data types, and objects work in GraphQL, talk about how we can make complex requests and even run functions against our requests. Next, I'll go over the different methods to actually execute a GraphQL call via HTTP, with both authentication and authorization methods that are supported by default. Then lastly, I will talk about some cool toys that come out of the box in every implementation of GraphQL. This brings us to the start. What is GraphQL and why does it even exist? GraphQL is a query language that runs over HTTP. It has a descriptive nature where you describe the object or the data you want, and the endpoint fills in only the fields that you are requesting or declared. In many ways, it shares a structure to SQL without some of the naming weight that exists in SQL. One of the best features of GraphQL is that it is both database and language or framework independent. Your backend data store can be performant SQL servers, extensible document databases, caching engines, or even unstructured data lakes. And you can build the API or the client app in any language that you choose. Included on the right is a very basic query. You simply toss this in the body of an HTTP request and you will get a JSON that is posted below it, a structure that most developers are already familiar with. Let's begin with the limitations of current APIs. Here's kind of the laundry list of current REST APIs when it comes to requesting data. The first issue with REST and SOAP in general is that there are too many API endpoints. The design of REST is that if you want an endpoint to deliver a different data model, you should build a new endpoint for it. This creates situations like what's seen here where you have 50, 100, 200 endpoints, all that send unique sets of data. And then when you expand it out, you'll see that you often have subversions of those as well based on the data model you want. There are also too few ways to modify data requests. For instance, if you want 5 computers in this example or only a specified detail about that set of computers, you either get too much data or too little. While modifiers exist in some REST implementations by either placing variables in the URI fields of HTTP GET requests, however, this has limitations of requiring each variable to have been coded and maintained, and you have to deal with the maximum length of the URI as well. So you end up with kind of a trade-off. You either are sending too much data to each request, or the person who's requesting data has to make too many follow-up calls, both of which tend to be expensive either on the time series or just general computing resources. So then we go to why you wouldn't just put a database connection in each of your applications and make the calls from there. You can even use abstract calls from libraries like Object Relationship Managers and Object Document Managers, ORM and ODMs respectively, that can wrap your database into easy to understand object calls in a language that you want to support. Even in the above case, you still run into the issue of requiring unique drivers for each database and running into unique implementation issues for those databases. Further, there aren't many certification frameworks where the application that runs on end-user devices allows you to even make a direct database call. Ultimately, the application and database are too coupled, and changes rifle through, or you are bound by early design choices without a method to add performance or extensibility down the line. This gets compounded in serverless application design as well, where you have to expose a huge swath of how the magic is getting done in your application. So we made some conjecture about the issues with REST and database connections, and how GraphQL is the magic pill to swallow for perfect data. Well, before that, we need to talk about how GraphQL does data schemas and data types. As described earlier, all responses are explicitly in JSON data types. So you have a huge limitation presented there. You can only have strings, numbers, booleans, and references to other objects. Compare this to MySQL or Oracle, where there are many different data types, ranging from variations of numbers, strings, dates, spatial, etc. Whether this is a disadvantage or advantage is best saved for another day. However, it must be acknowledged that JSON takes the lowest common denominator approach in regards to data types. The most powerful feature of GraphQL is the schema and type system. The entire query language is built upon types and classes. You can define an object, what makes that object, and the relationships, and then pass parameters to get the data that fits your model. Every GraphQL endpoint actually supplies a schema. In fact, in many ways, it's similar to the old WAR files and SOAP endpoints. Schema, validation, and object descriptions are all provided by the endpoint. Here on the right, though, we can see two types that I've created that we will be reusing in this discussion. The idea of a person and an address. Here you can see how they might link between each other. One unique feature of GraphQL, which isn't found in Python or JavaScript, every field is allowed to take arguments, and every field must be named if it takes an argument. Defaults, though, are allowed, and type hinting is available with provided schemas. In Python, it's common for a function or a class, which a type represents, to be able to pass unnamed variables and simply match the order of them. Similarly, that can be done in JavaScript, Bash, and just about every C language. By forcing the name into the argument, it makes the entire query much more readable, and you can be much more sure of what you're getting back in return. I included an example with the age value here, where it will pull the year as a calculated value. You can filter, sum, and do just about any form of aggregation function based on arguments in GraphQL. One truly powerful feature that was lifted from object-oriented design methodologies is the concept of an interface and the inheritance model that interfaces provide. Here I'm showing a very basic idea of an employee is a person. In any relationship that a person is valid, in an employee would be valid as well. The schema of GraphQL requires that the derived class must include all of the declared models found in the interface. Unlike Java, C languages, or Python, you do have to declare them manually if creating the schema class yourself. The loading will fail if an interface doesn't include each of the named objects. What makes this so powerful, though, and isn't available in REST systems without versioning controls, is an ability to allow multiple object types and extensibility. You can still have outlets for legacy models or reuse relationships for a new derived class. Of all the features, this one probably cracked my top 3 for GraphQL. I love the idea of being able to reuse code, models, and extend those to new classes. It makes for a really quick and fast coding project. You couldn't talk about interfaces and inheritance along with a SQL-like query system without talking about how unions and joins occur. GraphQL has two major types of unions. There is the preview view-like systems where an object may return a list of objects that don't share the same type. The second and more interesting is the dynamic search. In this case, you add a search command into the query and it will return each object that matches the types you add in it. Again, you can have arguments for filtering, joining, or just about any other named argument or aggregation function in there. Using these methods, you can create left join, right join, full join, and just about any other join method that's found in SQL in either a document database or a SQL backend. One unique value that will always be present, though, in the union is the underbar table value. It will often also have an underbar ID value. This gives you the breadcrumb to find exactly the type of data and relationships that apply to this specific object. This is important for updates or deletes and validation of objects. When it comes to execution plans on data gathering, GraphQL presents a modern system that many databases have struggled to implement. The execution plan includes a few key terms that should be known. Validation occurs when the query is received and also immediately before sending the resolved dataset back to the end user. Further, the initial validation is also provided in a similar fashion as to how WAR provides it in SOAP. The execution plan is fully written in TypeScript, but what is most important is that when a system that supports GraphQL is queried, it has what is referred to as a root node. It also provides a list of all of the endpoints and objects that you have read, write, or update access to, and the URI to do so with those. These are derived from your OAuth token. Further, all actions can be done asynchronously. Be careful though, all functions return a status code of 200. So to ensure that the action was done properly, check the body of the statement. That is the basic gist of what GraphQL is and how it works at a fundamental level. But but there are a few other areas that are really cool that make GraphQL a growing favorite amongst developers. The first is simple HTTP and HTTPS calls. Even in restrictive environments, because this looks like a standard HTTP call, it won't likely get filtered out by an ACL rule on a firewall. It also leverages heavy investments that have occurred in HTTPS security and protections. With full headers available, you have OAuth, basic auth, NoAuth, pre-shared cert, and a ton of other authentication and authorization tools available that are accredited and maintained. SSO is even available on endpoints. Due to edge firewalls blocking so much content, this gives developers a SQL-like ability to query datasets, but not have to ask for unique ports to be opened by security admins. The next cool toy, and this is a favorite for working with data engineers and AI modelers, gzip is supported in the header by default. Because JSON is the data structure, a gzip can see a total data reduction of over 80%, which is really useful when making a query for a large dataset. Being able to reduce the number of calls and get a larger data faster makes AI models quicker. You can also use this to populate HTTP pages as a JavaScript significantly faster than simply rendering the HTTP page. You can also reduce the total number of TCP packets to lower chances of data loss and subsequent follow-up requests, and reduce the number of sessions to prevent DDoS-like conditions from these pesky things called users. To request a gzip version of the data, simply add the variable and a true value into the header, or you can add it to the accept variable that's already existing in GET requests. The last two I'm going to cover really quickly. Pagination is enabled by default, allowing the breakup of large datasets into manageable sessions. These can also be called asynchronously. Server-side batching is available as well, and you can query a set and it will return the full set. Further, caching is available, but the caching between the GraphQL layer and the database layer must be manually defined. Lastly, a jobs token is available by default. A GraphQL can provide a token to refer to a job, and you can query with the token to find whether it has resolved. These features are found in various REST systems today, but having them 100% guaranteed to be present and implemented makes for developing lightning-fast applications much easier. We have covered all of the topics so far. However, not everything can be perfect, so I'm going to talk about the three biggest disadvantages to using a GraphQL endpoint. The first is, no matter what, it returns a 200 series status code. You must check the body of the response to ensure that the command was successful or the data was successful. You are, however, given a validation engine from the schema files, so you can also validate the response prior to returning the result to the application. However, this still is kind of an annoying step. The next is complexity. GraphQL supports JSON, gzip, pagination, a vast array of auth models. You may get a job token and not the result, and that doesn't even get to the point that you have to craft every query. HTTP GET requests are amazing when you can craft the perfect response to the application, and still would probably be faster. Lastly, if you are maintaining a GraphQL, caching is not enabled by default. The caching engines and the trade-offs are well known in the database area, and the status codes are generally accepted in REST. However, the translation layer hasn't yet flushed this specific area out yet. GraphQL is quickly becoming a favorite for the next generation REST. It is used frequently by app developers to help solve both performance problems and extensibility problems in application development. This service will continue to grow in favorability over the coming years, with both ORM and ODMs developing methods to abstract the database completely away. AWS, Mongo, and other document cloud database providers have all implemented GraphQL right out of the box for your documents, and can build schemas off of the collections and pipelines that you have already built. I've put a list of sites that have endpoints that will allow you to play with GraphQL directly in your web browser to show off the power of this language. To date, I personally include GraphQL template on every one of my boilerplate web apps or iOS applications. GraphQL has fundamentally changed the way I approach developing data models for applications and allowed me to think of the model more than the database. Thanks for joining me, and I hope you learned something.